we're going to be covering LeetCode problem number 994, which is marked as a medium level problem, and it is rotten oranges. So you're given an m cross n grid where each cell can have one of the three values: 0 representing an empty cell, 1 representing a fresh orange, or 2 representing a rotten orange. So every minute any fresh orange that is 4 directionally adjacent to a rotten orange becomes rotten. So that means any fresh orange that is a cell with grid value equal to 1, that is 4 directionally adjacent, that is a neighbor of the rotten orange, that is grid cell value equal to 1. So for example, if we have a 1 in any of the 4 directions, then in the next minute only all these would be converted to rotten, that is all these would be converted to rotten oranges, that is equal to grid value of equal to 2. Now we need to return the minimum number of minutes that must elapse until no cell has a fresh orange remaining. So we have to return the minimum number of time till the point where we have no cell as grid value equal to 1, that is no fresh orange available. If it is impossible, then we return -1. Okay, so now we check here, grid is equal to 2 1 1 1 1 0 and 0 1 1. So let me draw this. So if this is the grid, that is we have 2 1 1 1 1 0 and 0 1 1. 1 means that we have a fresh orange at these cells, and 2 is a rotten orange. So basically, let me just mark it as completely red. That means this is a cell that is rotten. So technically, you basically need to traverse this entire grid in a fashion that is level by level. So you must basically agree that we will be performing BFS, right? Since we are going level by level. So once this is basically at time t is equal to 0, we have this as red, right? So it can go either in this direction or this direction. So that is level 1. So it basically, the rotten orange infects or basically rots the nearby fresh oranges that are marked as 1 at level equal to 1. So when level 1 is cleared, the time is basically plus 1 incremented by 1. Then level 2 would be basically going over to these regions, right? This area, and this area. This would be level 2. But since 0 is basically an empty cell, we cannot infect that. So we instead infect or basically rot those oranges that are present with a grid value equal to 1, right? So now time incremented again by 1, so t is equal to 2. Level 2 has been covered. Now this would also basically, the rotten oranges would further rot any fresh oranges that are 4 directionally present in their vicinity, right? So obviously this cannot go because that would be out of bounds. So these cannot go up or down here, but this can go down and it can rot the orange, that is level equal to 3, and time again incremented by 1, that is 3. And finally this last cell, we again rot this orange, and that is level 4, and time incremented by +1, which is time is equal to 4. So we basically take t is equal to 4 to basically traverse it using BFS and rot each orange. So in this diagram also, you can diagrammatically see that it first in time equal to 1, it rots these oranges, then it further rots these 2 oranges, right? Because these are 4 directionally present, that is, this is to the right of this, and this is also to the right of this orange. Then in the next iteration, in the next minute, it rots this, and finally it would rot this in the minute 4. So that's our answer. Now in this question, let us see the next example, that is 2 1 1. If this is the grid, the example 2 is 2 1 1 0 1 1 and 1 0 1, right? So the orange, let us start rotting it. So basically we need to convert a grid cell equal to 1, that is a fresh orange, to 2 when it is 4 directionally present to a rotten orange. So at time t equal to 1, let us start our traversal, BFS traversal. At t is equal to 1, it basically rots this orange, and this basically gets converted to 2. Now at t incremented by 1, we have gotten to the level 2. So it converts these oranges to rotten. So plus basically we have converted the grid value from 1 to 2. Now it visits this cell from here or here. It's the same thing. So it becomes 2, and the time is also incremented by 1 because now we are at level 3. And finally at level 4, it traverses. It basically goes to the level 4 and increments the counter by 1 more. But as you can see, we are at a point where we cannot. You saw that these were the cells which were blocked, right? So we could not get to this orange that was present here, right? So the time would actually be 4 is not the correct answer, because we would actually return -1 since we are not able to rot all the oranges. Since these cells are not traversable, that is, we cannot reach them from any of these cells, so we cannot rot this fresh orange that is present here, right? So it remains fresh. So the orange in the bottom left corner, as you saw, row 2 column 0, is never rotten because rotting only happens 4 directionally, right? And similarly, the one more example we have 0 and 2. So the time would actually be 0 because there are no oranges to be rotted. There's no grid value equal to 1, right? So this remains as the rotted orange, and this is an empty cell, or you can say you cannot traverse that, right? Since there are already no fresh oranges at minute 0, the answer is just 0, right? So that is about the problem, and you also saw we are going to be performing BFS. So let's go with the intuition. The approach is to count all oranges, iterate through the grid to count all non-empty cells, that is 1 for fresh, 2 for rotten, and we queue up the rotten ones. So all initially rotten oranges are added to the queue to serve as BFS starting points, right? All the rotten oranges, that is all grid cells that are marked as 2. So the X and Y coordinates will push into the queue because these would be the starting points. And there could be multiple starting points because there could be a case in which we have multiple rotten oranges present in the cell. That is 2 is present here and here, and let us say it's also present here, and we have 1 1 1 0 1 0, right? So we start at all these points to rot the oranges, right? So these coordinates would be pushed in for the rotten oranges initially because they serve as the BFS starting points. So it would be a multi starting point for BFS, right? And third point is to start a BFS traversal. So for each level in the queue, which represents each minute, levels represent the minute as I had shown you. So as the level counter increases, the time counter is also increasing, right? So process the currently rotten oranges. For each rotten orange, look in the 4 directions, that is up, down, left and right. So 4 directionally we are going up, down, left and right. If a neighbor is a fresh orange, that is if the grid value equal to 1, we change it to 2, that is we rot it and add it to the queue. We change it to 2 and we add it to the queue, that is queue.push it. Okay, and then we track time, increment the time after each BFS level is covered only if new oranges were rotted. And final check is if the number of oranges we processed equals the total number of oranges, we return the time. That is, our aim is to basically rot all the oranges and we return the time if we are able to rot all the oranges, all the fresh oranges present. So we keep a fresh orange counter, that is the counter of the initial number of grid values equal to 1. So let us say we have 4 number of fresh oranges. So we need to maintain a fresh orange counter, that would track the number of oranges initially that were not rotted, and we need to make that equal to the number of oranges that we have rotted, so as to get our complete our rotting, right? And we return the time in case those values are equal. Otherwise we return -1 because we could not rot those oranges, because the case you saw for example 2, we had the case like this, that is 2 1 1 1 1 1, right, and 0 0 here. So this orange is not available to get rotted. All these would get rotted, right? All the remaining ones would get rotted, but we cannot reach this because we have zeros here and they are blocking the way to reach and rot the fresh orange. So this would not be converted, and in that case we return -1. Okay, so that is basically our approach that we follow. And complexity is O of m cross n because every cell is visited at most once during BFS, and the space complexity is O of m cross n because the queue may contain up to all oranges in the grid in the worst case. Now let us go to the code part. So it's a simple code. Let me just talk you through it. So basically we are going to perform BFS and we need to find the minimum time required to rot all oranges. That is the main purpose of our problem. So oranges rotting is our main function, and we are passing the grid in it, right? It is a matrix. So if grid is empty, we return 0, obviously. Now m is the number of rows and n is the number of columns, and we set the time initially as 0. Total is basically the counter we set for the total number of oranges, and counter is basically going to be total is basically counting the fresh and rotten oranges, that is total oranges, as I said, and counter is basically going to keep the count of the oranges that have been rotted. Okay, and we maintain a queue of a pair of int comma int rotten to store the rotten oranges coordinates at t is equal to 0, that is xy initially, right? So the starting coordinates we will push in. So for I is equal to 0, I less than m, so going over all the rows and all the columns. So for all the coordinates we are traversing, if grid of ij is not equal to 0, that is in the initial part, if the grid value is not equal to 0, that means it's either 2 or 1, right? So if in case it is 2 or 1, that means that we have either a rotten orange or a fresh orange. So total we increment, that is the total count of fresh and rotten oranges that we maintain. And if grid of ij is equal to 2, that is if the value is 2, that means this is a rotten orange. So we store the rotten oranges and push it into the queue, right? Push into the queue, and we maintain the directions that is going to be storing up, down, left and right, and we basically start our BFS here. So while the rotten queue is not empty, in case rotten dot size, that is the size of the level, and the number of basically rotten dot size would initially store the number of rotten oranges present, right? That is the size rotten oranges present, that is initially at time t is equal to 0. Okay, so this is rotten, and counter we increment by k. So counter is going to store the value of the rotten oranges initially, and we have stored it in counter because we would be updating the k and decrementing it in every iteration. So while k minus x is rotten dot front dot first and y is rotten dot front dot second, so we extract the x and y coordinates from it of the rotten oranges and pop out that element. So for int I is equal to 0, I less than 4 and I plus plus, we're going over going over each cell and traversing it 4 directionally, right? So neighboring row and neighboring column, x plus dxi and y plus dy. So if it is basically in bounds. That is, if the neighboring row less than 0, neighboring row greater than or equal to m, and neighboring column less than 0 and neighboring column greater than or equal to n. That is, if it does not go out of bounds, that is, if the cell that we are going to in the next iteration is valid. That is, if it is not going out of bounds, right? So if it stays in bounds, and also the grid of neighboring row, neighboring column is not equal to 1. That is, if it is not a fresh cell, then we continue, because we have not found a fresh cell. We have instead found an empty cell that might be equal to 0, and 2 we haven't found basically because 2 is already pushed into the queue, right? So in case this is not there, we continue, and if we get out of this, it means that we have a cell equal to 1. So we would rot that cell, since that is our aim. So we mark it as 2. That is, now it is rotted. So we rot it and we push it into the queue, rotten.push the coordinates, the next row's coordinates and the column. And once we get out of this loop, that is, one level has been traversed, we check if the rotten queue is not empty. That is, if we still have remaining elements inside the queue. That is, if we pushed in a fresh orange and it has to be rotted, then we increment the time counter, right? And finally, we basically check if in case our total counter, that is the number of oranges initially, is equal to the counter, because we also need to make sure that all the fresh oranges are rotted, right? There should not be a case that any one fresh orange remains as fresh and has not yet been rotted. So we check if total is equal to counter, then we return time, and in case all the fresh oranges have not yet been rotted, then we return, or not could not have been rotted, then we return -1. As we saw in example 2, we return -1 because the cell here was unreachable, right? So the cell with value 1 was unreachable, so it could not be rotted. That is where we return -1. So this is the check for that, and that is the solution. So that's it about the video.